we probably can get started. Lex, you want to give yours the kickoff?
Hi everyone. Thanks for joining today's session. It's titled Go SWE-Agent. So this means software engineer agent. It's a very cool AI tool that can help you write software. And George will give you a very impressive demo after this. So we are the ITAs, IT Association of Canada, a group of IT professionals, used to be Microsoft Most Valuable Professionals. And this is actually our new series of AI-related sessions. We currently decide to go online because it's not easy to find a conference room at Microsoft Office. Okay, so yeah, George has been a very passionate developer on AI-related technology, dates back even to GPT-1 and GPT-2, and he has also contributed to very famous AI-related frameworks, such as semantic kernel, also from Microsoft. So I'll give all the time to George so he can introduce SWE-Agent to all of you.
Yep, thanks, Lex. Welcome, everybody, to join us tonight. We're going to talk about language model-powered software engineering. It's a very exciting topic. If you just follow the news recently in March, there was one company announced something, Devin, and call it the first AI-powered software engineer. And the demo, they are very fancy demo on YouTube. Their AI agent actually pick up a job from Upwork and complete it by itself. Yeah, I know there are very controversial comments over it, and people believe it's kind of fake. But however, the open source community comes a lots of counterpart and actually pair to this kind of performance. And SWE-Agent is one of it. It's actually the state of the art tools at this moment, and it's open sourced. By the way, even people believe the Devin is a fake. They recently get investment with a value for $2 billion. So this SWE-Agent was commented on Twitter by a very famous NVIDIA researcher as a $1 billion project. Anyway, so let's get started. Before we go into dive into the content, introduce myself. I'm George Chen, software engineer and the tech lead. I've been working on multiple AI integration applications. Also open source contributor. Enough about myself. The objective of today's presentation is to dive into the strategies and techniques SWE-Agent applied in their project, and hope we can learn and use these strategies and techniques in our own projects. It doesn't matter we have something already started or we are probably going to come across some ideas in the future. I do think it's very valuable things to learn, and it's really totally going to be worth it. We're also going to take a closer look at the challenges and the limits in this territory. So we have I think if you're just not living under the rock, you probably have heard lots of language model use cases recently, like a RAG, summarizations, content generations, and code generation, code assistance. However, all these applications prioritize enhancement in user interactions through AI-driven conversational capabilities. For AI agent, we expect it to reason through a problem, create a plan, execute a plan, and choose the right tools to solve the problem by itself with no or very minimum human interventions. This becomes one of the hottest topic and the new frontier, increasing research and development effort. In terms of software engineering, as we always heard, okay, AI going to replace programmers. Let's look at it. What's the current status? What's the so-called state of the art performance at this moment? As what I mentioned, the Devin, which was valued 2 billion, they claim they can solve 13.84% of SWE-bench. SWE-bench is a data set with 2,300 GitHub issues and pull requests. So this tool, they claim it can automatically solve 13.84% of those issues. For the open source counterpart, SWE-Agent, is claimed to 29%. So think about it. I do believe it's far from replace a true programmer, but let's see what actually the potential and why we are talking about it today.
Yeah, this helped. Yeah.
Okay.
Thank you.
So this is the chat I was talking about. Sorry, I just talking to myself. So SWE-Agent 12% and Devin, the closed version, 13%. That's the current state of the art performance we are seeing here. So there are several highlights of this SWE-Agent. That's what they think they're kind of unique and distinguished to other projects. They create something called ACI Agent Computer Interface. And this is interface for the AI agent to communicate with the environment by sending input, which is action it wants the environment to execute inside the environment, and feedback, which called observation, that's the execution result from the environment. It created a special interface. Actually, we're going to take a close look into the code, how it's implemented. Actually, it's fancy in the name, but I think everybody can do it. And it also provides a set of tools to help the agent to conduct its job. So as one is the viewer, file viewer. Another, for example, is a searching tool, and also using a linter to check the syntax error returned from the language model from the AI, even before executing this code block. It will do a linter to check grammar error and the feedback to the language model, and also is fast. So let's look at it in action. I'm going to using Azure GPT-4, the latest version, February 15 preview, and to solve this issue's GitHub issue and ran just from my terminal. You can run it from Docker as well, but just for the demo purpose, I won't just run it from here. Can you see my terminal?
No, I cannot see it.
Okay, sorry. Let's just share it again. Share it again. Technology. Just give me a moment. Share it again. Let's share the whole window. So here's the command I'm going to execute. It's supposed to just do the task by itself without human interaction. So we only see the logs from the output, but SWE-Agent does provide a tool to look into the conversation, the message exchange between the model and the local environment. So I have it hosted here. So this two, I have my two history executions. Can you see it from there?
Yep.
Yeah. Okay. So I can post. Shoot. Alexa, I don't have I don't have chat permissions. But anyway, if you want looking for your site, you can do something like you can type in your browser awekeningbyte.com, and you can browse it by yourself. Let's just briefly explain what you're seeing here. So first, you see the system message is giving the context of the agent, what's your role, and what tools available to you. You're going to see your your programmer and thing, and here there's command you can use to describe the command and the argument, and give some kind of response format as an example, and tell only execute one command at a time, is setting the context of the system. But be aware, this SWE-Agent created by Princeton NLP team, they're not a production team. This is actually for their academic research paper. So don't copy this system message. It doesn't have a lot of security defense against like a prompt injection, and to avoid a kind of a bad faith use. So, but this is still give you an idea on what you're going to include into your system message, how you set the context, how do you communicate your AI language model, what's available, what's tool available, what's kind of a response going to be like, but you need to have a careful engineering on the security part. Anyway, so let's continue. It give a demo. The demo is a history resolving steps you provided to the language model, so language model can learn from it to understand what steps going to be involved to solve a GitHub issue. So this is something. If I see the language, the SWE-Agent did something really good, I can save it and provide it as a demo here. We're going to take a close look into the implementation later, but this is a high level describe what's the message exchange between language model and your agent. Now, this is the user message. User message actually just tell what's the issue is. So under the hood, our agent going to fetch the GitHub issue, and actually you need to check into the commit, which commit this issue is introduced by, and all the details about the version of the libraries, and copy the relevant code, reproduce code, and the issue descriptions provided to the language model. So once the language model see all the context, also providing instructions. Language model going to understand everything, the issue, the system background, context, and tools, and then decide what to do next. So it's going to come something called thought. And in SEW, they call it discussion. Anyway, this called thought. It's pretty much the plan what the language model think it's going to use to proceed to the job. So the first thing he says, I want you list all the fires.
Hey, Judge.
Yes.
Judge, sorry. So your screen, the screen just like stuck, or you are trying to demo something? So we just see the static terminal.
Oh, you are seeing a terminal.
Yeah, still terminal.
James. I'm really sorry. I'm really sorry.
Okay.
You can actually go to the link to here, but just repeat. So we have a system message. System message give the system context, and we provide a demo. And we have the issue loaded into user message. If you're familiar with prompt engineering, that's different role, right? So system role, you provide a system message. You provide a demo. Actually, demo come with the system message. We then have the user message, user role to provide the issue itself and giving some instructions. And this coming from the template I'm going to show later. And once the language model received all the things, it will decide, okay, I want to list all the files under the current folder. You see here, it's actually a bash command. It's not the customer command that we provide in the system. So the language model understand that you are in a bash environment because we provide this information in the system message. We also provide a customer tools, but the language model going to decide when to use which tool by itself. That's reasoning. So once it get the information, it decide, okay, I want to look into this model chain file, and back and forth, you're going to see the environment receiving this kind of command is called action from the assistant, the AI, and it's going to conduct these actions in the environment, and the environment actually under the hood is a Docker image. And the Docker image execute the code and giving back the output and back forth to the assistants. That's pretty much the flow of this thing. So let's back to the slide. Just let me know if you see my slide or not. Do you see the slide?
Not it.
Oh, Teams. I'm on the Linux. Teams seems doesn't work well on Linux, but hopefully
Yeah, now we can see it.
I don't interrupt too much. Okay. Yeah, let me know. So it just that in the action. It's not important how it looks, but we want to look into it is how we can do it by ourselves, or even better, how we can use this code base as a base to make our own tools. So you can see my page, right? The major components page, right?
Yep.
Yep. Okay, great. All the fancy things, I would think that there are some marketing words. Actually, if you're looking into code, I think most software engineer with maybe 3 years or less than 3 years experience going to understand and be able to work on top of it. So trust me, I'm going to show you. First, we're going to know there are 4 major components that we're going to look at. There are some supporting and the utility tools there, but let's just focus on this 4 thing. The environment is a class to handle, initialize a Docker container, set up the environment. That means inject all the customer tools into the container, and communicate. That means sending actions and reading the output from a Docker container. So that's called SWE environment. And the agent is the one, the brain actually talking to the language model, parsing the output, and sending the action and to SWE environment, and receiving the message called observation and forward to language model. And the model actually is using the out-of-box OpenAI or Azure OpenAI libraries, and with abstraction on top of those. And configuration is where we can configure those customized tools, the prompts, prompt templates, and things. So if you're going to looking into the code base, the repo by yourself, and you can focus on this 4 thing as a start. So under the hood, this what happened. First, when we start Python, ran.py is actually going to creating a Docker container. And once the container created, it's going to clone the repo, because we send the issues, right? It's going to actually clone the repo, and also going to set the correct version of the repo, because as what I mentioned, they go back to the commit where the issue happened, the issue was reported. Once the environment is set up, the agent going to this is wrong. It's going to reading the system message template, populate the placeholder with the environment variables with the argument, and generate the system message. If we want to give a demonstration, it also load the demonstration, and also fill into the system message template. Once the message template ready, it's going to send to the language model, and language model going to send back what the thought, that's the plan, and what action the agent going to take. Actually, thought is just for explaining purpose. Only the action going to be taken by the agent and sending to the Docker to execute. All execute output received by agent and then forward to the language model. That's called observations. At this time, the agent going to choose based on different observations. The agent going to choose different user message template to generate. But anyway, the interaction flow is like this. If you are working it, you can have your own logic, have multiple templates, and to suit for you, that's you can follow the suit. But the main logic is very straightforward and simple. Once you have an initialized environment, have the system message, it just loop from sending a message, receiving an action request, and sending the action result back forth to the model until receiving a point you need to stop. Either the problem the problem is resolved, or is reaching a certain threshold, like your use of certain tokens, the cost is reaching the limits, or you have being stuck into same command multiple times, it chooses to stop. This diagram is what I draw because I think for engineer we probably more kind of familiar with the sequence diagram, but for here this provided SWE-Agent, their documentation is pretty much same idea, but with some a different chat flow. So you take the task, you have the system message, you load the demonstrations, and you load the issue, that's the user message, and send to the model, execute, and take next step, you get actions and feedback, that's the loop. So the main logic is very straightforward. So far, any question? Okay.
Yes.
So
yeah, George, there's one question in the chat. Can you take a look?
You can unmute. Could you show us what the model do? Yes. So let's just first looking at to here, and then I'm going to show you the code. It's very straightforward. So what the model do is you're looking into the system message. That's what it do. First, the return you all this message. If you imagine this is ChatGPT, you can reproduce everything on ChatGPT. You just need to manually execute the action in the Docker container and copy the output from the Docker container as your user message is sent back. You can manually reproduce the whole thing on ChatGPT web UI. So the magic is the language model return you a format response that's described in your system message, because your system message requests that you respond in this format, right? So it's with discussion, format your output using two field, discussion and the command. Actually, is strictly following the instructions. The agent code, our own code, we implement the code to parse this output is a pure text and extract the command and sending this to the Docker image to execute in the Docker images terminal and fetch the result and return to the agent, and then we can send this to the language model. If you're talking about code, I'm going to show you the code. It's very straightforward, only one line. Does that answer your question? Okay. Yeah. Just if you still have questions, that we once we finish the presentations, that we can actually discuss. Have a quick discussion session. So, what we need to pay attention to, or what we can learn from it, is I think is valuable if you want to build your own AI tool, especially this kind of a tool to solve your specific domain problems. Like I was working on building a tool to automatically respond to support requests like a service accident. And this is definitely I'm going to use into my implementation, my code. So look at it. The first, the React pattern. This is a large language kind of prompt pattern. And actually, it's very straightforward. That's exactly what we saw in the trilogy viewer. You have your AI to reasoning and to acting. The reasoning and the acting. The reasoning is a thought. The acting is the command is sending back to solve complex tasks by interleaving, that's the loop we are seeing, a series of steps. So they call thought, action, and observations. And this term, you're going to see they strictly using in the code base. So it's very easy to follow. And they receive the feedback from the environment, which called observations. So if you're looking at the charge, all these things, like you found the one, this is statement, all these things actually say open this file, and all these things, observations, actually the open command was executed in the Docker, and this is the output, all in text. So React actually is a very simple and a straightforward, and actually the most effective prompt engineering style pattern so far has been used, and you're going to see it's pretty much everywhere. Thought actions. Actually, this thought are going to be ignored because your code won't be able to understand it. But the actions is definitely you're going to execute in your own environment and send the output as feedback, as observations, and back and forth as a loop. Also, another thing is tool use. All these things is actually very straightforward. If you take a close look at it, tool use is pretty much just everything you're writing in the PowerShell, even in Python. If you want, it can be any executable writing in .NET, and you describe it to the system. Just tell them, okay, this tool is available, and this is how you're going to use it. I'm going to mention function calling later, but this is something not function calling. It has much longer history than function calling, and it's very effective. But doesn't matter you're using the older React command actions or tool use. It's very important part, and actually it provided a set of tool for your AI and clearly describe its purpose and functionality and usage to your specific target, your objective. So the AI can have a clear command, clear action to take, and they can expect some much better quality result. That means observations. Tool use, that's what Andrew and recent comment. It's a design pattern I can go to work fairly reliable and worth learning about. So other perspective we're going to look at is to narrow down the complexities. So for open-ended software engineering tools, it's probably not going to be very useful at this moment. I know there are several of it, and I personally have been using Open Interpreter. If you're interested, check. That's a really good project, and you should take a look. Open Interpreter, and I made PR to it. It can do a lot of work, even creating kind of web application from scratch, but it's very unreliable. It's unpredictable. If you want to do a an automatic tool like to support your service, to monitor errors and to monitor errors of your service and take actions, you probably need to narrow down to very specific area of it. Like you're doing Kubernetes support, you're going to monitor a deployment, you provide all the kubectl command, your own customer scripts or PowerShell scripts to certain repetitive jobs for diagnosis, for automating tasks. Yeah, narrow down your focus. And also, it's very popular to talking about the multi-agent collaborative agent system. You're going to hear about AutoGen, Crew AI, but honest to say, for production level of things, they're not quite ready yet. They're very expensive and also very slow. The speed is a problem. So for SWE-Agent, it's a single agent system. Actually, it can execute subroutines and start another agent to get the result. But mostly it's a single agent. There's no agent collaboration. It's using another agent to do a branch task, but it's not collaborating between agents. And that's what I say. It's only designed for specific category of task, like GitHub issues. And also it's using controlled environment, like a Docker container, and with all the command, with all the environment variables controlled by the agent itself. And one of the thing Open Interpreter is running on your native host. So I ran into a lot of library conflicts, and there's potentially security risk as well, because it's going to automatically install package by itself, by its own decision. I think maybe we can introduce another PR to have Open Interpreter running in the virtual environment. That's something I probably can look into in the future. And also, it's taking one action at a time. So that's make SWE-Agent be able to achieve 28% of score. As an engineer, when we design a similar systems, and this all the things we can learn and we can consider until GPT-5 coming out, with GPT-4 for kind of a feasible solutions to a production level of things, and this the point we can learn from. Okay, this is some comment I see from X. The main reason the huge jump from naive implementation on top of GPT-4 to a specialized one, It's all talking about the point, because specialized, it's not open-ended. It's not just saying take your job and doing any software engineer development job. And also look into this agent computer interface. It's just a bunch of commands. Make the language model to browser this repository, because it's solving a GitHub issues. So this tool is specially designed for working on code repositories and view and edit code files and execute code. So if you are building your own agent using this kind of workflow, I can imagine you're going to have your own interface and own tool set. We're going to look into how it was implemented, and so maybe you can borrow these ideas and their implementations. So for a language model agent, it's using this command to talking to the terminal and getting feedback. They claimed without using this ACI, their result was much worse. Probably, I remember they're talking about only reaching 1.7% compared to now they have 12.28%. So take a close look at the tool they provided to the language model. This is actually a shell script. Describe the signature, and there's a documentation that's using a language, a natural language to describe the purpose of this function, so then the language model know when and how to use it, and the argument. You can create any kind of things. That's what I said. It could be a Python, could be a JavaScript, or shell scripts. And this is their, if you go to their Git repo and they're talking about, and even they're bragging about their kind of design the editor to limit the window size to 100. This is it. Actually, just a bash script. So we probably can take a look into the code itself. It's the time to look into the code. What's there? So can you see my Visual Studio? No, VS Code.
Yep, I can see it.
Oh. So I just give you a quick run to put some breakpoint, and that's when I just went through the whole things. When we ran the script, they have to provide a run PI, a create agent object, and creating the SWE environment as what I described. This thing actually internally create a Docker image, and this is the abstraction to all the communication to the Docker image. And if you're looking into how the environment, SE environment, communicate with the Docker image, just one line. So this command actually is a string. And the SWE environment writing to the standard input, the pipeline directly, it got executed. So it's very straightforward, and I think it's smart. Now look into the model. I think Su Hong, you asked about the model itself, right? Here are all the models is using. So you can use a human model. That's you mimic the AI. You're typing everything, copy and paste. Or you can use a GPT model. That's OpenAI. And you can also Claude, other models, or Llama, and they're all abstracted into a model class. And let's take a close look into the OpenAI model. Here are the OpenAI model defined in the code. And they using an OpenAI client provided by OpenAI. So in here, the query is this familiar with you? It's calling the client and chat endpoint and the completion. It's pretty much exactly the same on your official OpenAI documentation website. That's the only line is communicate with the language model. However, this response going to be parsed. That's what I said, going the response following the response format and going to parse by the agent. So in here, the agent going to do the loop. That's React loop. Yes, this model created from Azure AI service. That's what I said. I'm using Azure OpenAI. If you look into the code base, and it's very clear. And one thing I have to give a really high kind of comments to the SWE-Agent is they have a really well-designed software engineering on their implementations. They are very well-designed abstractions over all the classes, over the layers, over the components, and the clear interface between each other, and follow the solid principles like open close. There are multiple inheritance here, and single responsibilities. So it's pretty impressive. Before I start learning machine learning and AI, that's from 2013. I think my advantage was I'm a software engineer. I know all the best practice and the software engineering principles, so can help the researchers to implement their result, their output into the industry with the correct software engineering rules. And now you look at to those researchers from Princeton. It do a great job in software engineering, and I would say it's better than probably 80% of our normal developers. It's very impressive. Sorry, I just go from here. So environment, that's the SWE environment. Communicate, you see, that's where it's sending the actions. It's called step. Oh, the one more thing you should look into here is they have something called a reward. So that means they are going to, at this moment, they're not using reinforced learning, but I think they already have this in mind, and they put a placeholder here, a reward. And actually this SWE-Agent, I think SWE environment or inheritance from Jim environment, this is provided by OpenAI for our reinforced learning. So I do believe in the next version or later future, they're going to introduce improvement to this project with reinforced learning, and which actually is also a lot of other projects is talking about. But the reinforcement learning has its unique challenges, and so probably we haven't seen much yet, but it is coming. Unfortunately, this reward is not being used. It's get ignored. So stay tuned. And here, everything returned from the language model in this output is going to be checked and parsed into 3-part thought action output. So the code is pretty much there. And they also have very intensive kind of README documentations. You can take a look. All right. So let's go back to our slide. So you can see my slide.
Yep.
So all that's being said, there are still limitations. You go to see it's only 1247. I think I do believe 1228 or something like that. Percentage on the SWE-bench dataset I have to point out this SWE-bench set was created by Princeton team as well. So the same team with SWE-Agent. So they test on their own data set, they only get this performance. So we have to really reasonable, realistic expectations to what current AI can achieve. And for this SWE-Agent, as only working for Python-based repo, because if you look into the code implementations, it's actually Python-based. And as what I said, reinforced learning hasn't been implemented yet, has to be continued. Be aware of these limitations and look into how they how they solve some kind of challenges like communicate and like a limited complexity. We're going to come with some potential improvement. So there's one idea called RAG reflections, and let's just talk about RAG first. You see, we provide a demonstration here, and it's just a fixed demonstrations. But actually, a smarter way is when you get the issue, you're going to search the relevant similar issues you have been resolved before, and using that to provide it as a demonstration to language model, and that can greatly improve the performance of solving this issue. And that was a tool I was building to for my company to resolve service instance, and that's definitely are going to moving forward to using SWE-Agent patterns and learn from here in that tool. Also, reflections is another language model prompt pattern. It's using the AI agent to critical the plan the AI is proposed. So before we just taking the response from the AI execute, and we have another agent, or we have some tools to validate the agent, the AI output, and give a feedback. Actually, it's very similar idea. So this SWE-Agent provide a link to check the Python syntax. It's kind of similar to this reflection pattern. Actually, if you are doing it, you probably can provide some kind of a unit test tools, a unit test the suit, and to give feedback, or using something .NET CLI or Kubernetes CLI to validate your scripts. A similar idea. And also using function calling, because function calling is more powerful than this kind of a direct in response action format. I'm not going to go too in depth into function calling, but function calling is going to using JSON and going to have structured data returned, and it's going to be more flexible. We can also add in human feedback in the loop, because everything is kind of finished by itself, but actually we can intervene in the middle if you want. I mean, all these things in the future, if you're doing your own tools, that's all you can consider. And there's another really good paper, Can Language Models Solve Competitive Programming? And they talk in several of these techniques in that paper. This paper just released actually last week. It's very inspiring, and they claim they can reach something 20% to solve the competitive programming by applying this new applying these techniques. As what I said, Jim Fan, this guy worked for NVIDIA, it called it $1 billion repo. And I actually kind of agree with him. So here's the takeaway. Lower your expectations. Actually, the weak point is the reasoning part. And we hope GPT-5 can change it. Sam Altman has keep talking about don't bet against GPT limitations because GPT-5 going to crush you if you're a startup. We are working on those things. So let's cross our fingers. If we have a better reasoning tool, better reasoning models, and this tool can really take off, you're probably going to see 40%, 50%, and hopefully 60%. And that's to make it really productive level of readiness to apply in our industry, in our domain. And as what I said, limited complexity, only focus on small subset of your problems. Clear your problem scope and prepare the tools for AI to use. And prepare the environment, because a lot of times we can control the environment and provide it an isolated environment to the AI to safely conduct work. So here are the reference I used to prepare for today's presentations. I'm going to send a slide and probably writing a blog post about this content. And maybe Thursday can take a further look into those. So, oh, there's one more question. Is this model trained by feeding data to it? Could you tell me what the model can do in your project? Oh, so this is just Azure OpenAI GPT-4 model. Actually, is a base model, or it's called foundation model. It's not specialized for the coding, but you can fine tune a model to your task by giving your own instructions. Actually, that's a better solution, better way, because for the foundation model, they're big, they're expensive, and they're probably not really good at your specific domain, the problem set. But you can fine tune, not necessarily GPT-4. You can fine tune a Llama 3. You can type. You can do code Llama. Yeah, a much smaller language model with the provided code, provided instructions. That means that's why people saying data actually is most valuable things, because only you have access to those data. Like you are doing a kind of financial advisor, you have a lot of confidential conversations, and nobody else can access. And you can use those things as instruction to fine tune a model. A much smaller model actually can perform much better. So what are we talking about? SWE-Agent or Devin, they all rely on a model actually to provide the reasoning to act as a brain. And we provide all the kind of utility supporting capability to make those models to interact with outside environment. But the model itself going to have the logic. Okay, thank you. Any other questions? Okay, if no other questions, I think I can call it here, call the end. Anyway, stay tuned. I'm going to keep working on this area. I think it's very valuable things learned, really worth your effort to look into it. If you're a software engineer, it's really something are we going to expect if we do have like Sam Altman claimed against GPT-5, we're going to see a takeoff, a lot of this kind of things and performing much better. But the overall flow, the overall idea, the overall technique under the hood, pretty much going to be very similar, but with a way powerful brain. And you see the potential. So I really strong recommend to learn in this area, but at the same time to keep your domain knowledge. No matter you're working in finance industry, you're working in data science, you're working in software development, be an expert on your own domain, and this tool combines your domain knowledge, going to make you a big win in the future. That's my dream. Okay. Yeah. Thank you,
Yeah,
everyone.
thank you. Thank you, Devin. Yeah, so this is the end of the session, and like George mentioned, we will host similar sessions in the future, and you're welcome to register again at the ITA meetup page. So yeah, thank you for staying with us for an hour, and show you the page again. So. Yeah, you're welcome to join us another time with this or the other AI topics. Yeah, thank you guys.
Thank you.
Thank you, George.
And have a good night. Yeah. Bye.
Bye.